In this video, I'm going to do just a quick demonstration about how to add vertical and horizontal shifts into the function. And so I've got my function defined here, actually a bunch of pieces defined for my section. I'm just going to focus on this little top piece here. And when I click on that top piece, it actually will highlight the function here that I have. So the two sliders that we're going to add are H and K. H would be horizontal, our horizontal shift. And what we want to happen is visually, when we make A larger or H larger, we want to see the whole graph, that little part, get dragged to the right. And as we make it smaller, we want to see it get dragged to the left. We want to see it move to the left. And with K, we want to see this move up and down. So as K gets larger, we want to see it move up. And as K gets smaller, we want to see it move down. Anytime I'm messing around with a function like this, I always make a copy of the thing that I have. So I've got this picture, and I don't want to lose all the work that I did there. So I just copied it and I hid the original. So now I'm going to play around with this version. So if we wanted this to move left or right or up or down, let's think about up and down, because that's going to be the easiest thing to think about, particularly with these linear functions. Um, this equation here, if I get rid of this part, right, has a y-intercept of 3.5. So if I were just to add k onto the end of the equation, so just same equation, just added k, this is going to change the y-intercept, and it's going to move that function up and down. So essentially, right, that is the exact behavior that I want to see. I want to see that when k gets bigger, I want to see it move up, and when k gets smaller, I want to see it move down. Now you notice that, right, I got rid of the restriction, so I'm seeing the whole line. I'm going to put the restriction back, and it's going to work out because our restriction is in terms of x. It doesn't matter what the k value is. It's just going to define this window. It'll move up and down inside that window. So that works great. Now let's think about h. So I could, as long for any of these that I have the restriction defined as the x window, I can just go in, plop the k's in, the whole thing will work fine. H is going to be a little trickier because again, if I go back to the function, normally we would be thinking about x minus h, that quantity there. And as I drag h to the right, I want to see this move right. And as I drag h to the left, I want to see it move left. It's not doing that. You can see what it's doing, in fact, is the same behavior I saw with k. It's just moving the y-intercept. So visually, how do we get that to look the way we want it to look? Well, let me just think through it for a minute. So let's say I wanted to make this thing go to the right. I drag it to the right. What that means is I'm going to have to move along the function a little bit to have this illusion that it's moving to the right. The whole function's changing, right? But I'm going to create this illusion that it's moving to the right. And the way I do that, if I put my restriction back in, I'm going to put a minus h in this restriction. And what that's going to do is, as the function moves, as it moves up and down, this changes the window so that now it looks like this whole function is being translated to the right or to the left. Okay, so this is a little bit trickier, right, than the k. The k was just add the k, it moves up and down. Here, I had to also mess with the restriction to get it to look the way that I want. And depending on how your restrictions are for the different functions, you might need, right, a combination of changing the function and changing the restriction to make it visually look the way you want.